Good afternoon, students. I will start with the class. Yesterday, I think we had done around 11 problems. So today will be 12 problems. So this will be 13th one. Okay, so question is if x is equal to, according to write the numbers, I think the correct number. If x is equal to sine of 1 upon m log y, prove that 1 minus x square d square y upon dx square x divided by dx minus n square y is equal to 0. Okay, so this is the question given and you have to prove this. So we are doing high order derivatives, means you have to differentiate it 2 times. I'll take this question. X is equal to sine of 1 upon m log y. Okay, so in case if this is like this, if there's an x here and sine is this sine, instead of keeping it complicated, what actually you can do is take this sign on the other side. Okay, so if you take sine on the other side, it will become sine inverse of x. Okay, this will be 1 by m log y. Okay, and then m you can also take this side. So overall the question will become m sine inverse of x is equal to log y. So this is simple enough. Just one term this side, one term this side. M is anyways a number. You don't have to worry. Now differentiate with respect to x. Okay. If you want, you can write log y this side, m sine inverse x that side. Doesn't matter. Now differentiate. Find the derivative of sine inverse x. So sine inverse x is nothing but this will be m will remain m only. 1 upon root of 1 minus x square. Then take derivative of log y. Derivative of log y will be what? 1 upon y into derivative of y. So you can write it as y1 or divide by dx also you can write. But I'll follow that y1 only. Those who have joined late, I'll quickly repeat. This is the question given. If this is it, proof this. So I've taken the question. Sine I brought on the other side. So it became sine inverse of x. Then m also I brought this side. And now differentiate it. So it will be m sine inverse of x derivative is 1 minus x squared is equal to log y is 1 upon y into extra derivative of y will be dy by dx or y1. Derivative of y will be y1. Okay. Now either you can square on both the sides or directly also you can multiply. So denominator should be on the other side. Okay.
मैं मोबाइल पर डालो हाँ खाता हूँ ओ ओय
Okay, so one proportional
वाचलेले क्रिस्मस आता कोणा ऑनलाइन क्लासेस चुकल्या पळय ते टीचर्सान थिंग शिकपाकच जाय कंपल्सरी क्रिसमस दिवाळी वेकेशन कटिल्ड
mic on. Just mute the phone, someone's. Someone. Okay. Now you can differentiate second time. Okay, this is without squaring if I'm differentiating. Okay, those who have squared also will get the same answer. Now if you differentiate, this will be my1, okay, u into v. So 1 minus x square into derivative of y1 will be y2 plus v into derivative of u. y1 derivative of root x will be 1 upon 2 root 1 minus x square into extra derivative of 1 minus x square. So 0 minus 2x. Okay, 0 I have not written. 0 minus 2x will be minus 2x. Then you cancel. Okay. If you take without squaring, if you do actually see how it complicates. Okay, then you have to cross multiply like this. And then you can take it on the other side. I think it will become too much complicated if you do like this. Cross multiplication, many terms you will need. Then again, root x you will have to try to substitute. Still will give a try. My1. Okay, so when you multiply throughout by 1 minus x square, so this will become so root and root will become, this will go and will become like this. Okay. And now one last substitution. There's still a root sign. So instead of root sign, you can put it as my upon m1. What is root of 1 minus x square? My upon y1. So this will be my1 1 minus x square y2 minus xy. I can mark this as 1. And from 1, why am I doing this? Because in the answer there is no root. What I have done first, multiplied all the terms by root 1 minus x square. So that I get rid of this denominator. Okay, and then done the substitution. Then cancel, then you will get the answer. Take this term on the other side. You will get it. Or keep it like that only. So 1 minus x square y2 minus xy is equal to m square y. This is y1. No? Okay, so this is how you get the answer. If you want, I normally prefer squaring. This one example I have done without squaring. Only thing, all the substitutions and all you will do. You have to do. You don't square. So the answer will be m square y is equal to 1 minus x square by 2. So that's the same thing what has been asked in the question. Only thing they have written this side and this is on the other side. The next question you can try. X is equal to 14th one I guess. 10 of 1 upon a log y. Prove that x square plus 1 d square y upon dx square same like this previous problem you have to solve. Take this tan inverse on the other side. Okay, so I will just do the starting part and leave here, then I can solve. The question is x is equal to 10 of log y. This will become tan inverse of x, which will be equal to, okay, 10 I brought on the other side and a you bring this side, so it will be tan inverse of x log y, and then you differentiate and try. Same like previous problem. Only thing here you don't have to square because there will be no root sign. Directly, what will be the answer? Derivative of tan inverse of x will be 1 upon 1 plus x square. Log y will be same thing. 1 upon y into y1. Just give a try and then tell me if anybody has got the answer. D square y upon dx square means y2, huh? And this is y1. So I can solve by using y1 and y2 only. And last, just replace y2 as this. Anyone having doubt can ask, huh? Till here, if anybody has not understood, please ask. So, A, derivative of tan inverse of x will be 1 upon 1 plus x square equal to derivative of log y, 1 upon y into derivative of y will be y1. Then cross multiply. Take denominators on the other side and then differentiate. So from here, denominator will go this side and it will become ay. Same way, it will go this side. Now there's nothing there at the denominator. Here no need to square because there's no root sign. Then differentiate.
Dear God,
This is coefficient Whenever it's a pure number, don't use u into v. It will remain as a only. And derivative of y
I
will be
got it.
y1. Now this is u into v. Anybody got the answer?
Yes, teacher.
So u into derivative of v. This will be 1 plus x square into derivative of y1 will be y2 plus v into derivative of u. Now I want derivative of this. 0 plus 2x. Okay. U into derivative of v plus v into derivative of u. You can take this term on the other side. 1 plus x square y2 2x y1 minus ay1. And then take out y1 common. You will get the answer. This term I took it on the other side. Both places y1 is common. So this is what the answer has been expected. Anybody having some doubts, please ask. There's no point simply copying. Next question is y is equal to x log of 1 plus x upon x. Prove that x into x plus 1 y2 plus x y1 minus this previous one. If you are looking at the answer, it is same thing. If you want, you can replace y2 means what? Second order derivative, d square y upon dx square. And y1 means what? dy by dx. Even if you don't write, still the answer is correct. So y1 and dy by dx. Those who are wondering, this was not asked. Actually, this was asked, but it means the same. Okay. Now, y is equal to this. The question which is being given as log of 1 plus x upon x. Okay, instead of keeping it complicated, I'll use log of a upon b. So I'll write it like this and keep so that it becomes easy to take the derivative. Okay, so this is your u and this part is b. Okay, so next step you take u into derivative of v plus v into derivative of v. Why have I done this? Because u upon v formula I'll have to use. It will become complicated. First log of 1 upon that and into derivative of this. So whenever there is log, you can always separate it out using log of a upon b formula. Now you can differentiate. with respect to x. So when you differentiate, this will derivative of y will become y1. Then u into derivative of v plus v into derivative of u. And this will be y1. So derivative of this I have to take. So log of something will be 1 upon 1 plus x into extra derivative of 1 plus x. So anyways it will be 0 plus 1 minus log of x, straight away formula is 1 by x. Then plus v into derivative of u. So this will be log of 1 plus x minus log x into derivative of x is 1. Okay, so u into derivative of v plus v whole thing into derivative of u. Derivative of x would be 1. This is anyways 0 plus 1 will become 1. You might get multiplied. And you can cross multiply it. So y1 will be equal to x into, when you cross multiply, x minus 1 minus x upon x into 1 plus x. I cross multiplied inside. So minus will belong to both the terms. Here what I can do, I can write this back. Log of a minus log of b is what? 1 plus x upon x. Okay, this I just wrote back. X and x will cancel. Sorry, minus, yeah, plus x and minus x will cancel. Okay. Now, if you look into the question, okay, I don't want this log of 1 by x. Looking into this question, what is log of 1 plus x? For log of 1 plus x upon x is nothing but y upon x. So instead of that, what I will get is minus 1 upon x plus, instead of this, what I will get is y upon x.
Hello, teacher. Hello, teacher.
And then
Hello, teacher.
you can cross multiply again.
Hello, teacher. Hello,
So
teacher.
this is left now. Here, minus x. This will also cancel. So this will be 1 plus x. And now you can cross multiply. So this will be minus x plus y across multiplied again. Only this step you have to know. Log of 1 plus x, you look into the question and then put 1. You can mark that equation as 1 and you can write it as from 1 I got this. Why? Because if you see in the answer, there is no log. So I want to get rid of that log. Everything should be only in terms of x and y. So once I substitute, then you can cross multiply and simplify. So this you can take this side. So what it will become? X 1 plus x into y1 is equal to. So this is step which you will get. And now you have to differentiate for the last time. Okay, if you want, you could multiply this inside also and solve. Okay, this can be written as x plus x square. Same answer you will get. Or you can consider this as u. Now there are three terms. Okay, v and w. U, v and w. Suppose if there are three terms, you can avoid this also. You can just make it two terms also. But I've never taught you that u, v, w. So I'll just give you an example over here. There are three terms. So what is the formula? You take two terms at a time, take derivative of the third one. Okay, I'll just do it in the next step. I'll show you directly. So take the first two terms as it is. Don't take derivative one. I'm writing as it is. Now take derivative of the third term. So derivative of y1 will be y2 and plus. Take the next two terms. So 1 plus x, y write it as it is. Take derivative of the third term. So derivative of x will be 1 plus all the combinations you have to take. It's like a into b, then take derivative of c, then b and c, take derivative of a, then take a and c. X, y1 into derivative of this 0 plus 1. Okay, so this is how you have to use u, v, w. Suppose if there are three terms, take two at a time, take derivative of the third one. Okay, is equal to derivative of minus x will be minus 1 plus u into v plus v into u. Okay, so that's it. And now you have to bring all terms on one side and simplify. So this is what you will get. X into y2 1 plus x y1 plus x y1. I'm bringing this side, so minus 1 will become plus 1. This will become minus y. This also will become minus 1 plus x y1 is equal to 0. You see, these two terms are same. They will cancel. And write the remaining terms. And the same thing has been asked. Okay. This is minus, huh? Just change in the question. If in case I've given it as plus, this is minus y, huh? I think I gave minus only, just check. So final answer, x y2, okay, plus x y1 minus y plus 1 is equal to 0. So this is the answer. This was slightly complicated. Only that step of substitution you should know. Instead of log, have to refer equation 1 and then substitute. Anyone who has not understood this three terms? Move on to the next question. If y is equal to log of log x, prove that x square y2 plus y1 plus x y1 square is equal to 0. So this is what you have to prove. These are from the question paper. Huh? Okay, so this is the question. So directly take derivative. Differentiate, take this question, differentiate. Log will be, you can solve. So this is the question. You have to take derivative. Differentiate with respect to x. So now derivative of y will be what? y1. Now derivative of log of something. Log of anything is what? 1 upon that. So log of whatever is inside the bracket. So this into extra derivative of this, what is the inside. So what is the inside the bracket is nothing but log x. The derivative of log x is 1 by x. Okay. So this will be your answer after taking first derivative. Okay. This step will be next step. What you do is take any one term on the other side. So x will go this side. Okay. Okay. So this is what you will get. X I took here. So just bring it to the numerator. It will become, I've taken it up. If the power here is 1, if I take it up, it will become minus 1. And now you differentiate. This is like x raised to n formula. This is u into v. So when I'm taking derivative, u into v, x into derivative of y1 will be y2. v into derivative of u, derivative of x is 1, is equal to, this is now x raised to minus 1. So x raised to n formula is what? N x raised to n minus 1. Okay, into, was it x? No, so extra derivative of log x. Log x is nothing but 1 by x. So this is what you will get after taking the derivative. I use this formula x raised to n x raised to n minus 1. So to and what is there? Minus 1 is there. And then I took derivative of log x. So this will be xy2 plus y1 is equal to minus 2. So minus 2, if I take it back to the denominator, it will become plus 2. Okay, so this will become minus 2. I'm taking it back to the denominator. Now if you see, as per the question, in that proof, whatever you are asked to prove, you will nowhere find log x. Correct? So I have to do some substitutions to get rid of log x. Because I don't want, otherwise this would have been the correct answer. But there is something else asked to prove. Okay, in that there is no log. So try to get rid of this log. So you can see here everywhere if there's any log. So you can look at this equation. Okay, 1 upon log x. So as per that, what will be log x? If I take this off, log x is nothing but, I can mark this as 1. So just go back in that equation, okay, where you had written this, and write it back. I want a value of log x for me to substitute over here. Okay, log x is nothing but 1 upon x y1. So put this value over here now. Okay, so the moment you find something which you don't want, go back in the question and see where you can do the substitution. Okay, so here also, this also you could use. Take log x this side, bring y1 down, same you will get x y1. Okay, so I'm using this value over here. So x y2 plus y1 is equal to minus, instead of log x, I'm putting, it will become whole square. Okay, so I've got rid of log now. Now just simplify, means square this and then the reverse. So this will become 1 upon x square y square. And then 1 upon something, we go back reverse. Okay, and then 1x will cancel and bring this term on the other side. So this is what we get. If by mistake, if I've given in the question x square, then just cancel on. This is the correct answer. X y2 plus y1 plus, this is y1, no? Y1 square will be equal to 0. This is x y1. Okay, so this is the correct answer. In case suppose if I given by mistake x square, just cancel it. It is x y2. Anyone having doubt? Only this step is different, right? You have to substitute back. Otherwise, it was normal. Same derivative you have to find. Then this substitution you do and simplify. Next question. y is equal to sine inverse of x upon root of 1 minus x square. Prove that 1 minus x square y2 3xy1 minus y is equal to 0. So what you can do, take this root on the other side and then differentiate. You can just take 1 minus x square into y is equal to sine inverse of x and then differentiate. So u into v formula you have to follow. So differentiate, this will be 1 minus x u into derivative of v. So that will be y1 plus v into derivative of u. So root of something will be 1 upon, okay, into extra derivative of this is equal to sine inverse of x will be 1 minus x square. 2 and 2 will cancel. Now just to get rid of this from the denominator, multiply throughout by everywhere. All the terms just multiply by root of 1 minus x square. When you multiply over here, root into root will give me simple one. So here this term will go. So this will be minus xy you will get. If you want, you can take one extra step and solve. Finally, you will get this is equal to root and root will cancel. This will be 1. Now you differentiate again. Again u into v, u into v. So 1 minus x square. Derivative of y1 will be y2. Y1 into, so this is for this. Now here be careful, huh? Minus is outside. Now I'm using u into v for these two terms. So x into derivative of y will be y1 plus, okay, so minus will belong to both the terms. Y, okay, because this was minus. If this was plus, you don't have to worry. But if it's minus, when you're applying u into v, put it in the bracket. And then derivative of 1 will be 0. Now simplify. And that will be asked, whatever is asked in the question you will get. So this will be minus xy1 minus y is equal to 0. This and this similar terms, minus 2 minus 1 will be minus 3. Only two more problems left. That's 17th, I guess. 17th, just write it down. After solving so many questions, now you should be able to solve, okay? Like, if anything of this type comes. You have to practice it once without looking. You just have to write a question and try to solve the entire problem. If you are able to solve from first to end without looking, means you have understood it. You will not forget also. But after every step, if you are referring the notebook to see what is done next, means there is some problem. You have to do it till you are able to solve without looking. Okay. Now don't bring the sign in this side. Huh? If you notice, this is y, not x. So it will become complicated. If you bring sign this side, it will become sine inverse of y. And again, if you differentiate, you will get 1 minus y square and all, which we don't want. Okay, only if this was x, then you could bring sine this side. But whenever it is y, don't try that. If you have noticed in the previous problem, if you go back and see when we had brought sine this, it was x. Okay, not y. So directly you differentiate. Take the question and differentiate. So y will be equal to, y will become y1 when you take derivative. Now sine of something. Sine of x would be what? Consider this to be x. Sine of x will be cos x. And then cos of that, whatever is the inside the bracket, into extra derivative of what is the inside the bracket. So what is there? M is there and sine inverse is there. So derivative of sine inverse will be 1 minus x square. So this is what you will get after first derivative. The sine of something is cos of that. Okay. And then extra derivative of what is inside the bracket. So this is the inside the bracket of sine. So I've taken extra derivative of this.
Into minus 2x.
So root to take it on the other side. Don't keep anything at the denominator. So it will become
Sure.
like this.
Into minus 2x.
Okay. Now differentiate again.
Hello. 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 Hello.
Do into the formula. This root I brought this side. Huh? Now u into derivative of v. So y1 will become y2. V into derivative of q. 1 minus x square, 1 upon 2 root x into extra derivative. So anyway, this will be 0. Straight away I'll write minus 2x. Okay, minus x square, that will be minus 2x is equal to, m is a coefficient, so you don't have to worry. Now it is cos of something. So cos of something is what? Minus sine of that into, continue there, huh? in a notebook, you write ahead. So into derivative of again m sin inverse of x. This is what you will get after taking derivative. Okay, derivative of cos is minus sine of that into extra derivative of what is inside the bracket. And then multiply throughout by 2 and 2. So that I get rid of the denominator. Multiply all the terms by root of 1 minus x square. So here denominator will go. And this will become single. So it will be 1 minus x square by 2 plus into minus will give me minus x by 1. Okay, this and this term will cancel. It's equal to minus m into m will become m square sine of m. So this is what we will get after multiplying all the terms with sine inverse of this root of 1 minus x square. Here it will cancel. Here also it will cancel. So whenever I'm saying multiply means all the terms I'm multiplying on both the sides. And now one last step. If you notice, this is turned out. Okay, I don't want it. And it is, if you look in the first question itself, what is the value of this? Can anyone tell me what it will be? What will be the substitution in that?
Y.
Y. So this will be and then you can bring this from on the other side, it will become plus. And you will get the answer. Minus, you bring this side, it will become plus equal to 0, you write. So one good thing about this question is you know whether you have got it correct or not. Because they will tell you this is what you want, the answer. The last one. Prove that x raised to 4, this is 4, minus 1 y2 plus 4x cube y1 is equal to 4x. X raised to 4 minus 1 y2 plus 4x cube y1 is equal to 4x. And this is also from question paper. Those who have finished already derivatives in their college and all should be able to solve all these problems. Because these are the types of questions which will come in the board. So whichever I'm solving right now, or majority, almost 60 to 70% are from the board. Only few I have done extra. The rest will be similar. Take this as a question, like tan inverse of x. So whenever there's a log function, I told you always try to simplify it. first of all, root can be written as raised to half. Okay. This will become half. Okay, whenever there's a power, it will always come out. Just before just make this minus and this plus, huh? Otherwise it will go entirely wrong. Now in your chain. Numerator is minus, denominator is plus. Otherwise it will become ulta. This term will come here, this will go that side. Okay, make this minus, denominator is plus. And now open up this bracket, log of A upon B. I'm still not differentiated, I'm just simplifying still. So half will be common. So this will be log of A minus log of B. So when you open up this bracket, it always becomes easier to take this log. Otherwise, it will be U upon V again. Now you can differentiate. See any step over here? Anyone has not understood? I've converted this root as half, raised to half, because root can always be written as raised to half. Any power can always be brought out in log. So half I've written out, then use log of A upon B formula. Okay, so log of A upon B is log of A minus log of B. And half will belong to both the terms. If you don't put bracket, if you write only for one term, again it will be wrong. Huh? Now differentiate. So derivative of y will become y1. Derivative of tan inverse x will become 1 upon 1 plus x square. This will be half. Derivative of log x is what? X minus 1 into, suppose if you go to take derivative also, this will be 1 and derivative of minus 1 will be 0. Same way. Even if you don't write this, it's okay. I just want to know, those who don't know, what we normally do, log of something is 1 upon that into extra derivative of that. So derivative of this is 1, derivative of 1 will be 0. And then cross multiply. Okay, so it will be like this. Now cross multiply. Y1 cross x plus 1. Now minus will belong to both the terms. So minus x plus 1 it will become. X minus 1 into x plus 1. X and minus x will cancel. Y1 will be equal to 1 upon 1 plus x square half. Now a plus b into a minus b will be a square minus b square. This will 2 and 2 will cancel. So what you'll get is x square minus 1. Okay. By writing, you can write like this also. Both terms in the same form. Instead of 1 plus x square, I'll write it as delta x square plus 1. Okay. And now again cross multiply. So when you cross multiply, x square minus 1 upon x square plus 1 into x square minus 1. So x square plus x square, what will get is 2x square. So again use the formula a plus b into a minus b. So that will be, now instead of a, what is the x square? So it will be a square minus b square. So y1 will be equal to 2x square upon x raised to 4 minus 1 you will get. Then take this to the numerator on the other side. So this will be x raised to 4 minus 1 into y1, which will be equal to 2x square. And now you differentiate. And then you will get the answer, whatever is expected in the solution. U into V formula you use. So this will be to 4 minus 1 into U into V. So this is U, this will be V. So derivative of y1 will be y2. So y1 into derivative of x raised to 4 will be 4x cube minus 0. This will be 2 and this will be 2x. Okay. I think that's the answer what has been expected. So it will be x raised to 4 minus 1 y2 is equal to 4x. Okay, so this is all about this higher order derivatives or using implicit functions. Okay, the last topic which is left is on parametric higher order derivatives. So that I will do in the next class. Okay, I'll send some problems for you all. If I forget, just remind me. Okay, for you all to solve on this. Tomorrow I will not take the class. I'll take directly Thursday and Friday and finish off the chapter. Okay, just take attendance. Okay, so those who have copied can leave. If any doubts, can ask.